Let us look at this question, which is an excellence question at level 2 and even helpful for level 3 algebra. So find the value of k, find the exact values of k for which the quadratic equation x squared plus 2 times k minus 7 times x plus 4k minus 3 has no real root. So before we go, let us understand what does it mean to say that the quadratic equation, so look at this word, these words, quadratic equation has no real roots. So what does that mean? It means any quadratic equation becomes a parabola, okay? And if it has no real root, it means your parabola is not intersecting the x-axis. That is what it means graphically. Now algebraically, this means, if you want to put this in algebraic way, no real roots implies that your determinant, which is b squared minus 4ac is less than 0. Now where did I get this from? This I have got from the quadratic formula. X is equal to minus b plus or minus square root of b squared minus 4ac over 2a. This is a quadratic formula. Now if you think in a logical way, when would you have no roots? When this number is a negative number. And in real numbers, you can't have a square root of a negative number. So this is what it means in algebraic sense, that no real roots means this which is inside the square root is less than 0. That means it is negative. Okay, so if that is the case, we need to identify what is a, what is b, and what is c. So here a is the coefficient of x squared. Now of course you should be knowing a quadratic formula. Okay, quadratic equation has this form, or this is the general form of a quadratic equation: ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So comparing this with this, I can say a is 1. What is b? B is the coefficient of x. So this whole thing is your b. So it is 2 bracket k minus 7. And c is the constant, which is without the x. So this 4k minus 3 is the constant, or that is c. So let us put this ABC in this form, or in this relationship, which is an inequality. So I can say, well, this is 2 times k minus 7, k minus 7, oops, let me use a smaller eraser, k minus 7 the whole squared minus 4 times a is 1 and c is 4k minus 3 is less than 0. Okay, what happens now? I'm squaring both of them inside the bracket, so this is 4 times k minus 7 the whole squared minus 4. I'm not expanding this. I'm going to write this as 4k minus 3, which is 4k minus 3 is less than 0. The next step, I'm going to divide the whole thing by 4. Okay, so let me do that. So I'm going to divide this by 4, I'm going to divide this by 4, and also this by 4. So you will have, what is left over is k minus 7 the whole squared minus 4k minus 3 is less than 0. Okay, so now let me expand this. So this is k squared. This is k minus 7 times k minus 7, which is minus 14k plus 49. You can expand it yourself. I hope you can understand this. So minus 4k plus 9 is less than 0. So ultimately we can simplify this. So minus 14k minus 4k is minus 18k plus this is, I don't know why I wrote plus 9 there. It should be plus 3 there. Sorry. So this is plus 52 is less than 0. Okay, now here from here we have to understand this a bit graphically. Now if you draw, we want the exact answer, so we can't use the calculator. We can check, you can use the calculator later on to check the answer. So here, when let us use the method of completing the square and draw the graph, and then we'll understand it graphically. So completing the square, ignore this for a while. So this is k squared minus 18k. Now to complete the square, or completing the square method, is you take the half of negative 18, which is negative 9, and then square it. It's plus 81. Then you immediately take away 81, and then you already have got this 52 sitting here. It's less than 0. So this becomes a quadratic. This is a perfect square, and this can be simplified. So this is nothing but k minus 9 the whole squared, and this is minus 29 is less than 0. Now this, let us not look at this. Now this means, from this I can say, I can just look at this and can say the vertex of this quadratic equation. If you know graphing quadratics, we know this parabola has gone 9 to the right. It has gone 9 to the right, and it has gone 29 down. It has gone 9 to the I'll show this on a calculator. Okay, so the vertex I can say is how much? The vertex is 9 comma minus 29. Okay, so let me first graph this, and from this I can say, from this form I can say this directly tells me that the y-intercept is what? Y-intercept is when x is equal to, or k is equal to 0. Okay, x you can replace by k, yeah? So your y-intercept would be 52. Just by looking at this, I can say that the y-intercept is 52, and this is the vertex form. This tells me that the x-intercept, sorry, the vertex is 9 comma, or the x-coordinate is 9 and the y-coordinate is minus 29. So first let me draw it, and then I'll confirm this on a calculator. So this is the x-intercept, sorry, y-axis, this is x-axis. This is not drawn to scale, and this is, I'll have to move this slightly up. So this is again not drawn to scale. So what I'm saying is, this point, the y-intercept would be 52. The y-intercept is 52. This again, as I told you, this is your y-intercept. Your vertex has gone, this is your vertex. I'm talking, when I say the vertex has gone, I'm talking about from y is equal to x squared. Okay, so this vertex, I can say the vertex is 9 comma, so this is minus 29. So let us confirm that on a calculator. So this is 9 comma minus 29. So these are the two things that I can say from my equation. Okay, so let me get my graphing calculator out. So menu and graph. Okay, the equation was x squared instead of k squared. You can write x squared minus 18k x plus 52. Okay, I need to change the scale. So you go shift V window. I'm interested from say 0 to if you got 9 here, 9 is in the middle, so I'll go from 0 to say 0 to 30, okay, or 25. Let's try 25, scale of 5, dot, don't change the dot. I'll go from, I want from minus 30, because the vertex is minus 29 to 60, okay, and scale of 3. And then let me draw the graph. So here's a graph. Can you see this is a parabola? So I'll check. I want to confirm the y-intercept. So you go gsolve and y-intercept. Y-intercept is 52, and this is called the minimum. So minimum is 9 comma minus 29, just like that. So I know I'm interested. Now let us I'm interested basically at these 2 points. So the question is, if you look at this inequality, so we are asking the question, when would this, or this is a parabola, we're interested in those values of k which makes this parabola, or the values of the parabola, less than 0. So if you think about the parabola, this part, at this point, suppose at these 2 points, your parabola is equal to 0, or your parabola hits 0. For this point, these points, so let me use a black color. For these points, what is the value of the parabola, or what is the value of the function? The value of the function, or value of the parabola, I would say, is greater than 0. At these points, for whichever value, this is say x1, so let me call this x1, and this is x2. When x1, when your values of x are less than x1 or greater than x2, your parabola, the values of the parabola or values of the function is greater than 0. At this point, they're equal to 0, and when the values of x, which are between these 2 values, between x1 and x2, so let me write that. When x, we are interested in those values of x which are less than x2 and greater than x1. That is what we want to find. So basically, if we can find x1 and x2, we can say, we can write this inequality or relationship. Okay, so here how would you let us do without the calculator. We'll confirm this. So for the time being, let us say make this a quadratic equation. So can I say, let me use a different color. So I'm going to write this as a quadratic equation to solve this. So k minus 9 the whole squared minus 29 is equal to 0. I'm making this a quadratic equation, and so this means k minus 9 the whole squared, I'm adding 29 to both sides, is equal to 29. Okay, and now taking square root of both sides, I can say k minus 9 is equal to plus or minus square root of 29. So k is equal to, I'm adding 9 to both sides, 9 plus or minus square root of 29. So your x1, to be exact, is 9 minus square root of 29, and your x2 is 9 plus square root of 29. So does it make sense? So let us look at here our graph. Say this point, we are saying this distance is 20 square root of 29 away from. Can you understand? These 2 points are equidistant from the vertex. So let me draw the line of symmetry. So this is the line of symmetry, and it does make sense. So this distance is root 29 to the left, and this distance is also root 29 to the right. So x1 is 9 minus root 29, and x2 is 9 plus root 29. So we can say, you can say k is greater than x1, which is 9 minus root 29, and but should be less than 9 plus root 29. Okay, so let us check that on a calculator. Does the answer make sense? So these are the x, this is x1 and this is x2. So g solve and you go to root. This is, you can check that yourself. You go 9 minus root 29 will give you this, and if you go 9 plus root 29 would give you this. So let me show you that. So you go 9 minus root 29 is this, and 9 plus root 29, oops, 29 would give you this value. Okay, but the question was you had to find the exact value, so you can't use the calculator. You can check it, but you had to work this out algebraically.